All right, we're going to take a look at derivatives of inverse trig functions today. Let's kind of review inverse functions for a minute. If you remember, like the sine of x, here's your sine function. It kept going. Now, it was not one-to-one, right? It fails the horizontal line test. So it actually did not have an inverse, right? It's more than one time. But mathematicians got greedy and they said, hey, you know what? Let's force it to have an inverse. And so what we'll do is we'll just cut it off between negative pi halves and pi halves. All right, so they cut this off. And then it passed the horizontal line test. In other words, it is a one-to-one function. And so they flip-flopped all their x's and y's and created, all those points flip-flopped around became the inverse trig function, which went from negative 1 to 1 and from pi halves to negative pi halves, and it looks something like that every time you flipped all your, flip your x's and your y's, and we called it the arc sine, right? Flip-flop the x's and the y's, and that's where we got the arc sine function. Well, if you're doing these algebraically, knowing that the x's and the y's flip-flop, we solve things like, for example, the arc sine of negative a half, right? And we say, well, let's solve this, and we set it equal to something. Let's set it equal to theta. If that's true, then we know that, bless you, we know the sine of theta would be negative a half. Again, theta is between pi halves and negative pi halves, right? So then we're just looking on our unit circle between pi halves and negative pi halves for the theta. Sine of what gives us negative a half, and we say, oh, that's negative pi 6 or negative 30 degrees. We know the sine of negative pi 6 is negative a half. In other words, theta must be negative pi 6. So the arc sine of negative a half is negative pi 6. Well, what we're going to do today is we're going to go ahead and we're going to set these up. And for all these problems, we're actually going to assume x is positive. But we're going to draw the triangle in this first quadrant and set them up and then solve for these first couple. And then we'll start using that information or using that approach to take some derivatives as well. Let's look at this first one here. Let me erase this. All right, so what I'm going to do first here, I'm going to let that be theta. So let's go ahead and let that arctangent of 4x, I'm going to set that equal to theta. So if the arctangent of 4x equals theta, then remember the x's and the y's flip-flop, the tangent of theta would be 4x. And remember with the tangent, arctangent, you cut off the tangent between pi halves and negative pi halves as well. But we assume x is positive. So we're going to draw these into quadrant 1 always. Okay. So let's go ahead and set this up. We have the tangent of theta equals 4x, or 4x over 1. Remember, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangents opposite over adjacent, right? Or I was taught, oh heck, another hour of algebra for sine, cosine, tangent. SOHCAHTOA, same thing. Anyways, so we've got our theta here, tangent of theta. Whoops. Let me draw this triangle with theta in here. So tangent of theta opposite, adjacent. Okay. Let's go ahead and solve for that remaining side. So a squared plus b squared equals the c squared. That's my c right there. So I have 1 plus 16x squared equals c squared, square root both sides. So c ends up being the square root of 16x squared plus 1. So let me replace that with square root of 16x squared plus 1. Okay, now we've got this triangle. Remember, we let the arctangent of 4x, we let that be theta, right? We let that be theta. So number 2, oh, by the way, this was number 2, was draw the triangle, sorry. Number 3 is now take the secant of the arctangent of 4x. Well, the arctangent of 4x we called theta. So we're just using the triangle to find the secant of theta. And remember, secant's the reciprocal of the cosine, right? And cosine is adjacent over hypotenuse. So the secant would be hypotenuse over adjacent. So let's look at the theta over here and we say, oh, here's my hypotenuse, here's my adjacent. So it looks like the secant of theta is the square root of 16x squared plus 1 all over the adjacent, which is 1. Remember theta was our arctangent of 4x. So in other words, the secant of the arctangent of 4x is that square root of 16x squared plus 1 all over 1. And we've solved that. All right, so similarly on this one, let's go ahead and take that arcsine. We're going to let the arcsine of x minus 1 be theta. If that's the case, then that means the sine of theta would be the x minus 1, right? The inputs and the outputs reverse positions, right? Well, we know the sine of theta, SOHCAHTOA, that's, yeah, opposite over hypotenuse, right? So let's go ahead now and draw our triangle with theta here. Here's our theta. Opposite side would be x minus 1. Hypotenuse would be 1. And let's go ahead and solve for the remaining side. So I got a squared plus x minus 1 squared equals 1 squared. I'm solving for, this is my a right there. Right? Let's subtract this both sides. A squared equals square root of 1 squared minus x minus 1, x minus 1. Oops, that's just a now because I square rooted both sides. We got x squared minus x minus 2x plus 1. So the 1's are gone. And so I've got it being the square root of 2x minus x squared. Let me put it back up here. Square root of 2x minus x squared. Okay. And so step number 3. Now I'm taking the cotangent of the arcsine x minus 1. Well, we called the arcsine x minus 1, we called that theta. Right? So we're taking the cotangent of theta. Remember, tangent's opposite over adjacent. So cotangent would be, yeah, bless you. So my adjacent side, here's my adjacent side, here's my opposite side. I'd have square root of 2x minus x squared all over x minus 1. Now note, x can't be 1, right? In my denominator there. So that's my cotangent of theta. And then you can go ahead and fill in theta. The theta was the arcsine of x minus 1. Again, x can't be 1. Well, that leads us to finding a derivative of an arc, the arcsine of u in this case. So this is the proof. So what we're doing is we're proving that if y equals the arcsine of u, then y prime would be 1 over square root of 1 minus u squared times chain rule, whatever the derivative of u prime is. So that's what we're gonna show right here. Okay, so number one, we have y being the arc sine of u. So if I flip-flop my y and my u, the sine of y would then be u, right? And remember, this is the sine is opposite over hypotenuse, right? So let's go ahead and number two, let's draw this then. The sine, my angle in this case is y, so the sine of y is u, opposite side, over the hypotenuse 1, right? So if we solve for the third side, a squared plus u squared equals 1 squared. So a would be the square root of 1 minus u squared. So I solve for the third side. And so what we have now is we have the sine of y equals u. And what we're going to do is we're going to take that derivative with respect to x here. And so I have, well, I know that the derivative of the sine is the cosine of y, but these variables don't agree, so dy dx. And I'm going to write that as y prime. Equals derivative of u is just 1 du dx, or u prime. Okay? And so what we have is y prime equaling u prime over the cosine of y. Okay, so I'm almost there. All I got to do is find the cosine of y. Okay, so I go over to the side and I say, well, let me go over here and find the cosine of y. Well, that's adjacent over hypotenuse. Here's my adjacent side. So the cosine of y would be square root of 1 minus u squared over the hypotenuse of 1. So the cosine of y is just the square root of 1 minus u squared. Let me, by substitution then, replace that. So I have u prime over square root of 1 minus u squared. That's the derivative. So we just proved the derivative of the arc sine. So that's one of your formulas. It's 1 over the square root of 1 minus u squared times chain rule times the derivative of u. Okay. Let's do one more of those. Okay, here's my next one here. We'll go ahead and we're going to prove, this is our proof that the derivative of the secant is 1 over u squared of u squared minus 1 times chain rule u prime. This is what we're going to prove. So number one, if y equals the arc secant of u, then secant of y would be u, right? Then the secant of y would be u. Or in other words, well, secant of y is the reciprocal of the cosine. Cosine is adjacent over hypotenuse, right? So this would be hypotenuse over adjacent. So when you're setting this up, secant of y, you set this up. Here's our y. Our hypotenuse would be u, and our adjacent side would be 1. Then we go ahead and solve for that remaining side. So 1 squared plus b squared equals u squared. So b would be the square root of u squared minus 1. Let's put it in there. Square root of u squared minus 1. There's that remaining side. And so we have the secant of y equals u. And we're going to go ahead and take that derivative with respect to x here. And the derivative of the secant is secant tangent. Variables don't agree, so don't forget you got a y prime here. Derivative of u is just 1, but then variables don't agree, you got u prime. And then I'm going to go and I'm going to look at, and I'm going to say, oh, the secant, if you notice the secant of y, I'm going to substitute that in. What's the secant of y? Well, it's hypotenuse over adjacent, right? So our secant of y is u over 1. In fact, we already knew that. secant of y u over 1. So secant of y is u. So I'm going to replace that with u. Tangent of y, again, looking at my right triangle there, opposite over adjacent, so square root of u squared minus 1 over 1. So the tangent of y is the square root of u squared minus 1. So that becomes square root of u squared minus 1. So what do we have by substitution? I have u, square root of u squared minus 1. There's my secant y, tangent y. Y prime equals u prime. I'm solving for y prime, so I'm going to divide both sides by u, square root of u squared minus 1. So the derivative of the arc secant is 1 over u, square root of u squared minus 1 times chain rule u prime. So that brings us to all these formulas. And these are what we're going to use now. So we proved 2 of them. All right, that was the one we just did right there. And we also did that arc sine one up here as well. The very first one, top left. All right, so let's use the formulas now so we don't have to prove every one of these. The arc secant of 2x. Again, make sure you remember we're assuming x is positive, right? So the arc secant of 2x. So the 2x, that's our u, right? So we have y is the arc secant of 2x. And you just want to note we're letting u be 2x, right? So in other words, we have the arc secant of u. So once we take the derivative would be 1 over u, absolute value of u. I'm just using the formula, square root of u squared minus 1 times chain rule, derivative of u. Right? So let's just use that. So this would just be, let me come up here. So y prime would be 1 over u squared minus 1, and then I take the derivative of u, right? That u prime's on top. So the derivative of u, derivative of 2x, just 2. So y prime equals 2 over absolute value of 2x is the absolute value of 2 times the absolute value of x. I'm going to take that out. 2x squared, quantity squared is 4x squared minus 1. Notice the 2's cancel. So y prime just ends up being 1 over the absolute value of x square root of 4x squared minus 1. We did assume that x was positive anyways, but that's what you're using on that. Let's move on to this one. So this time we're going to let u be the 5x to the 4th. Right? And so we're using the fact that if I have the arc cosine of u and I take the derivative, I'm just looking up here at the derivative of the arc cosine right there. So that's, I got negative 1 over square root of 1 minus u squared. I like to put that u times u prime times the chain rule. I like to put that out to the side personally, but you can put that u prime up top if you want. So that's what we're following, right? When we take this arc cosine. So y prime would be negative 1 over the square root of 1 minus u squared. U is our 5x to the 4th, that's squared, times chain rule, derivative of the u, which would be 20x to the 3rd. Clean that up. Negative 1 times 20x to the 3rd, negative 20x to the 3rd over square root of 1 minus 5x to the 4th quantity squared. So that'd be 25x to the 8th. So here we're going to let the u be that 3x squared minus 8. And so it's in this form, the arc cotangent of u, right? So we're just looking at our formula sheet at the arc cotangent, which is negative 1 over 1 plus u squared times chain rule u prime, right? That's what we're going to use here. So we've got y equals arc cotangent of, we're calling it u, which is our 3x squared minus 8. Let's go ahead and do it with 3x squared. 3, come on. No. X squared minus 8 in for the u. So I got the y prime would be negative 1 over 1 plus u squared times the derivative of u. Well, the derivative of 3x squared minus 8 is 6x minus 0. So this y prime just ends up being our negative 6x over 1 plus 3x squared minus 8 quantity squared. And you could expand that if you wanted to. Would that be minus 24 minus 24 minus 48? Well, here we've got the arctangent of u, so the derivative would be, again, I'm looking at my formula sheet, 1 over 1 plus u squared times chain rule u prime, or in other words, u prime over 1 plus u squared. So we're going to go ahead and we're going to let the u be that square root of 5 minus 2x. Well, that's 5 minus 2x to the 1/2. So just note when you're taking that derivative, you've got chain rule involved here. You got 1/2. It'll be 5 minus 2x to the negative 1/2, and then derivative of the inside. Derivative of 5 is 0. Derivative of minus 2x is a negative 2. So this u prime ends up being negative 2 over 2 is negative 1. Negative 1 over the square root of 5 minus 2x. So just note what that u prime is when you're doing that, okay? All right, let's go ahead and, take the derivative. So the derivative is 1 over 1 plus u. Here's my u squared times u prime. Negative 1 over square root of 5 minus 2x. So this becomes, let me erase some of this right here. So y prime becomes negative 1 over 1 plus square root of 5 minus 2x squared is just a 5 minus 2x. And then you've got this stuff being multiplied by the square root of 5 minus 2x. So y prime just ends up being negative 1 over 6 minus 2x times the square root of 5 minus 2x. And that's the derivative of the arctangent of the square root of 5 minus 2x. This next one, notice we have the natural log of the arc cotangent. I'm going to go ahead and let that be u. So this is kind of like the ln of u, right? So the derivative would be 1 over u chain rule u prime, right? U prime. Well, if I had just the arc tangent, normally we have, if y is the arc cotangent of 2x cubed, normally we're letting that be u. Let me let it be v for a minute, right? Then the derivative of that would be, and I'm using the arc cotangent now, which would be 1 over 1 plus v squared. In other words, 1 over 1 plus u squared times, oops, that's a negative, and then times v prime, u prime. Okay, so this derivative would be negative 1 over 1 plus 2x cubed squared times the derivative of 2x cubed, which is 6x squared. So this prime is negative 6x squared over 1 plus 4x to the 6th. All right. That's the chain rule part. That's the derivative of the arc cotangent. So let's come back over here. So y prime is just 1 over the cotangent, 1 over u, right? 1 over that. And then we took the derivative of the arc cotangent on the side. That was the negative 6x squared over 1 plus 4x to the 6th. So this derivative is just negative 6x squared over the arc cotangent of 2x cubed times 1 plus 4x to the 6th. Again, 1 over u prime. But I had to go to the side and find the derivative of that arc cotangent of 2x cubed. All right, so this next one we've got a product rule. I've got derivative of x times the arc tangent of 2x, and then we'll deal with taking the derivative of that other side. Let's go ahead and do the product rule here first. So derivative of the first times the second plus the first, and now I'm taking the derivative of the arc tangent of 2x. Well, the derivative of the arc tangent is 1 over 1 plus u squared u prime. So the derivative of 2x is just 2. So there I've taken care of x arctangent 2x. There's my product rule. Now I'm going to go and address this. I got a minus. So minus the constant. Derivative of the natural log is 1 over that 1 plus 4x squared. So 1 over u times the derivative of u. Well, derivative of 1 is 0. Derivative of 4x squared is 8x. And so let's see what we got here. We got the arctangent of 2x plus 2x over 1 plus 4x squared minus 8x over 4. Now that's going to give me 2. So minus 2x over 1 plus 4x squared. Well, 2x over 1 plus 4x squared minus 2x over 1 plus 4x squared, those are gone. And so this just ends up being, those are like common denominators, right? This just ends up being the arctangent of 2x. Cleans up nicely. All right, here's our last one. We've got 25 arc sine of x over 5. So when I take that derivative, that 25 will stay there. The derivative of the arc sine is 1 over the square root of 1 minus u, which is x over 5, 1 over u squared times the derivative of u, which is the derivative, here's my u, derivative of 1/5 x, just 1/5. Minus, now I've got to do I'm going to do the product rule over here, right? This is a product, x times that. So derivative of x is 1, derivative of the first times the second, plus the first, derivative of the second. Well, that's 25 minus x squared to the 1/2. So I got to do 1/2 25 minus x squared to the negative 1/2. And then I got to do times the derivative of the inside, which is negative 2x. Well, 25 fifths, 25 times 1/5 is 5. So I got 5 over square root of 1 minus x squared over 25. Minus, and then I've got square root of 25 minus x squared. Let's see, I've got minus 2x squared over 2. So minus an x squared over the square root of 25 minus x squared. And then I'll distribute that. And over here, let me get a common denominator. Let me give that 25 and a 25. So this y prime ends up being 5 over the square root of 25 minus x squared all over 25. So I got 5 over, now I know I have square root of 25, so this is over 5. So that just ends up being, once I flip that, 25 over the square root of 25 minus x squared. Okay. So over here, and I'm going to get that being my common denominator. That's square root of 25 minus x squared. So this is over 1 right now. I got to give it a square root of 25 minus x squared. Square root of 25 minus x squared here. And so I got minus, so square root times square root will undo that. 25 minus x squared all over this square root of 25 minus x squared. So I got 25 minus 25 plus x squared all over this common denominator. So I got x squared plus x squared ends up being 2x squared over square root of 25 minus x squared. Well, thanks for watching. I hope that helps. See you next time.